In 1974, humanity did something that no civilization in recorded history had ever done before. We took the most powerful radio telescope on Earth, aimed it at a cluster of 300,000 stars, and screamed into the darkness. We told the universe exactly who we are, where we live, what we are made of, and we did it without asking a single question that should have come first. What if something is already out there, listening? Here is what makes this truly extraordinary. The scientists who sent that signal were not reckless. They were brilliant, decorated, celebrated, and they operated under one quiet assumption so deeply embedded in human thinking that almost no one thought to challenge it. That contact with an alien intelligence would be wonderful. But there exists a theory, built not from fear, not from science fiction, but from pure cold logic, game theory, physics, mathematics, a theory so internally consistent, so devastatingly coherent, that some of the greatest scientific minds of our time have called it the most important idea humanity has never taken seriously enough. It suggests that the silence of the cosmos is not emptiness, it is a warning, and we have already ignored it. If you want to understand what that warning means, stay with me, subscribe, so you never miss a journey like this one. Because what comes next will change how you see every star in the night sky, forever. You are still drifting. The blue world beneath you grows smaller. Its clouds swirl slowly, silently, catching light from a star that has been burning for 4.5 billion years. You watch it shrink. You watch the darkness around it grow wider. And somewhere in that growing darkness, a question rises quietly inside you. Are we alone? It is perhaps the oldest question humanity has ever asked. Older than telescopes, older than science, older than the written word itself. Long before anyone had instruments to search the sky, people simply looked up and wondered. Ancient Greek philosophers debated whether other worlds existed beyond the one they stood on. Roman poets imagined that the moon might have its own inhabitants, living lives not so different from their own. And medieval scholars argued over whether a god who built something so enormous would populate only one small corner of it. The question has followed humanity across every era, every civilization, every language. It has travelled with us through mythology and philosophy, through religion and reason, and finally into science itself. And through all of that time, through all of those centuries of wondering, the quiet intuition remained the same. Of course, we are not alone. The universe is too large, too old, too rich with possibility. It seems almost arrogant to believe that out of all this vastness, only one small planet produced something that opened its eyes and looked outward with curiosity. And slowly, through the 20th century, that intuition began to find scientific ground beneath it. As telescopes improved and our understanding of the cosmos deepened, the numbers became almost impossible to hold in the mind. Our galaxy, the Milky Way, contains somewhere between 200 billion and 400 billion stars. Many of those stars are older than our own sun by billions of years. Billions of years during which planets could have formed, cooled, gathered oceans, and perhaps begun to stir with something like life. And the Milky Way is just one galaxy. The observable universe contains roughly 2 trillion galaxies, each of them filled with hundreds of billions of stars of their own. When you sit with that number long enough, it stops feeling like a number and starts feeling like a kind of proof. Not scientific proof, but something quieter than that. A feeling that emptiness, on that scale, would be the strangest outcome of all. The sheer arithmetic of existence seemed to guarantee that life, including intelligent life, must have arisen elsewhere. The universe had too many chances to fail completely. But slowly, something changes. Intuition is beautiful, but science asks for more than intuition. It asks for a framework, a method, a way to turn a feeling into a question that instruments can pursue. In 1961, a young astronomer named Frank Drake sat down at the National Radio Astronomy Observatory in Greenbank, West Virginia, and tried to do exactly that. He developed an equation, not an equation designed to give a single precise answer, but one designed to map the shape of the question itself. The Drake equation, as it became known, is multiplied together a series of factors, the rate at which new stars form in the galaxy, the fraction of those stars that have planets, the fraction of those planets where conditions could support life, the fraction where life actually develops, the fraction where intelligence emerges, the fraction where that intelligence builds technology capable of sending signals across space, and finally, the average length of time such civilizations continue to broadcast before they fall silent. Many of these numbers were unknown in 1961. Several remain uncertain even today. But that was never really the point. The point was the framework itself. The equation made the search for extraterrestrial intelligence feel like science rather than speculation. It gave researchers a map of the unknown, a set of doors that could be opened one at a time, and when you put even modestly hopeful numbers into that equation, the result was striking. The galaxy should contain thousands, perhaps millions of civilizations capable of reaching across the stars with their voices. The universe, the math suggested, should be alive with signals. This idea captured something deep in the human imagination. For the first time in history, the ancient question was not just philosophical, it was technological. You could build a radio telescope, you could point it at the stars, you could listen. And so, the search began. In 1960, Drake himself conducted the first modern attempt to detect extraterrestrial signals. He called it Project Ozma. He pointed a radio telescope at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, and listened across the hydrogen frequency, a wavelength that seemed like the most natural choice for interstellar communication. He listened for months. He heard nothing. But the idea had taken root. If one telescope and one astronomer could do this, imagine what a dedicated global effort might achieve. Over the following decades, the search expanded dramatically. The Ohio State University's Big Ear radio telescope scanned the sky continuously for years. The SETI Institute, founded in 1984, built serious research programs around the question. The Allen Telescope Array was designed specifically to accelerate the hunt, and in 2015, a program called Breakthrough Listen launched with $100 million in funding, becoming the most comprehensive search for extraterrestrial intelligence ever undertaken. It surveyed millions of stars across multiple frequency bands, using algorithms designed to find patterns that no natural process could explain. The dream of contact was no longer a poet's daydream. It had laboratories. It had budgets. It had the quiet, patient dedication of serious scientists who believed that the answer was out there, and that with enough time and enough instruments it could be found. The assumption underneath all of this was fundamentally hopeful. Scientists believed that if intelligent civilizations existed out there, at least some of them would want to communicate. They would build transmitters. They would send signals outward into the dark, either deliberately as beacons, or accidentally as leakage from their own technology. And if humanity listened carefully enough, with sensitive enough instruments, aimed at enough stars for enough time, something would eventually emerge from the noise, a pattern, a carrier wave, a sequence of prime numbers that no known natural process could produce. Something that would change everything humanity understood about its place in the universe. The hope was not naive. It was grounded in logic. It was supported by the numbers. It was shared by some of the most careful and rigorous scientific minds of the 20th century. Carl Sagan called the search one of the most profound endeavours our species had ever undertaken. Jill Tarter, one of SETI's most dedicated researchers, described it as holding up a mirror to the question of what it means to be human. It was beautiful, this dream, gentle and enormous at the same time. But slowly, something begins to change. Because the universe, for all its generous arithmetic of stars and planets and possibility, has not yet answered. The instruments have grown more powerful with every decade. The methods have become more refined. The number of stars surveyed has climbed from thousands to millions. And through all of it, through more than 60 years of careful, patient, dedicated listening, the result has remained the same. Silence, not partial silence, not occasional silence broken by faint promising whispers, complete, unbroken, stubborn silence. Not a single confirmed artificial signal from beyond Earth, not one unambiguous transmission, not a repeating pattern that resisted every natural explanation offered to account for it. The universe answered our hopeful listening with nothing. And it is here, in this silence, that the ancient question transforms into something else entirely. Something quieter than hope. Something that begins to carry a different kind of weight. Because if the numbers are right, and the galaxy is full of worlds, and the conditions for life are universal, then the silence is not a simple absence. The silence is a fact that demands explanation, and the explanations that have been offered over the decades since the search began range from the comforting to the deeply, quietly unsettling. We are only beginning to understand which kind we are living inside. Man, the stars keep burning, the darkness keeps stretching, and you keep drifting slowly through a universe that seems full of everything except the one thing you are listening for. A voice, an answer, something that says, yes, we are here too, but the answer does not come, and in the space where it should be, something else grows, not panic, not fear, just a slow, widening curiosity about what the silence actually means. Because silence, it turns out, can mean many things, and some of those meanings are far stranger than emptiness. But slowly, something begins to change, and we will follow the search into its most extraordinary moments, the signals that almost were, and the universe that kept its secret anyway. You're still drifting through the dark. The stars around you hold their positions like ancient sentinels, burning quietly, giving nothing away. And somewhere far below, on that small blue world you left behind, people are building instruments, pointing them at the sky, turning up the sensitivity, leaning in closer to the silence, convinced that somewhere inside it, something is waiting to be heard. The search has begun in earnest now, and it carries with it something rare and beautiful. A quality that only appears when science and wonder meet at the same crossroads. It carries genuine, open-hearted hope. The year is 1960. A young Frank Drake sits at a radio telescope in the quiet hills of West Virginia, headphones on, listening to the universe. He has chosen two nearby stars that resemble our own sun, Tau Ceti and Epsilon Eridani. Both close enough that a signal, if one existed, might be detectable with the technology of the time. He has chosen the hydrogen frequency, 1420 MHz, a wavelength that exists naturally across the cosmos and that any technologically advanced civilization might logically choose as a universal channel of communication. He listens for months. The universe says nothing. But something important has happened. For the first time in human history, the question of whether we are alone has been pursued not with argument or philosophy, but with an instrument, with data, with method. Project Ozma may have heard nothing, but it proved that listening was possible, and possibility in science is everything. The idea spreads. Through the 1960s and 1970s, radio telescopes across the world begin contributing to the search. The Soviet Union conducts its own programs. American universities build dedicated listening projects. The question moves from the fringes of scientific respectability towards something approaching mainstream curiosity. In 1971, NASA commissions a study called Project Cyclops, which envisions an enormous array of radio telescopes working together to scan the sky with unprecedented sensitivity. The project is never fully built, but the report it produces becomes a foundational document for everyone who follows. It maps the technical requirements of the search with extraordinary care and establishes the intellectual framework that will guide CT research for decades. And then comes Big Ear. The Ohio State University Radio Observatory, nicknamed Big Ear, is not glamorous. It is a flat reflector telescope built on farmland, run on modest budgets staffed largely by volunteers. But it scans the sky with quiet persistence, year after year, logging signal after signal, searching for anything that does not belong to the natural world. It is Big Ear that will produce the most famous moment in the entire history of the search. But that story belongs to the next chapter. For now, what matters is the spirit of the place, the dedication, the willingness to listen for years without reward, sustained only by the belief that the universe is too vast and too old to be silent forever. But slowly, something shifts in the nature of the search itself. By the 1980s, the technology has improved dramatically. Computers can now process far more data than human operators alone. Signal detection algorithms can scan thousands of frequencies simultaneously. The search that once required a researcher sitting with headphones listening manually becomes something more systematic, more powerful, more capable of finding a needle in the electromagnetic haystack of the cosmos. In 1984, the SETI Institute is founded in California. It brings together astronomers, engineers, and researchers under a single institutional umbrella dedicated entirely to the search. Jill Tarter, one of the most respected scientists in the field, becomes its public face and its intellectual heart. She spends decades arguing that the search is not science fiction. It is science. The Allen Telescope Array follows. Funded partly by Microsoft co-founder Paul Allen, it is designed specifically for SETI observations, an array of small radio dishes working together, capable of surveying large portions of the sky across multiple frequencies simultaneously. It represents a new generation of listening infrastructure built from the ground up for one purpose: to find a signal that should not exist by natural means. And then, in 2015, the search takes its largest single leap forward. Breakthrough Listen launches with $100 million in private funding from investor Yuri Milner. It is the most comprehensive, most sensitive, most systematically ambitious search for extraterrestrial intelligence ever attempted. It surveys millions of stars. It covers a wider range of frequencies than any previous program. It processes data with algorithms capable of identifying patterns that no known natural source could produce. Breakthrough Listen is not a gesture or a symbolic effort. It is a serious scientific program operating at the frontier of what human technology can achieve, and it brings with it a quiet intensification of the original hope that Drake felt back in West Virginia in 1960. The universe is full of worlds. The instruments are finally powerful enough. Somewhere out there, something is broadcasting. We just need to find the right frequency. The cultural dream of contact runs parallel to the scientific one throughout this entire period. Films and novels explore what meeting another intelligence might feel like. Carl Sagan writes Contact, imagining a signal from the star Vega carrying instructions for a machine that could bridge the distance between civilizations. Steven Spielberg's Close Encounters of the Third Kind portrays aliens arriving not as conquerors, but as musicians, communicating through melody and light. Even stories that treat aliens as dangerous frame contact as something humanity can ultimately survive and grow from. The dominant cultural assumption is clear and consistent. Making contact might be frightening, it might be overwhelming, but it would ultimately be meaningful, transformative, worth whatever discomfort came with it. This optimism rests on a chain of logic that many serious scientists find persuasive. For any civilization capable of communicating across interstellar distances must have survived long enough to develop extraordinary technology. Surviving that long presumably requires cooperation, stability, and the wisdom to manage existential dangers without self-destruction. Therefore, truly advanced civilizations would likely be curious and peaceful, rather than recklessly aggressive. The very qualities that allowed them to endure would make them inclined toward exchange rather than violence. It is a comforting argument, and it is widely accepted. But slowly a different kind of question begins to grow at the edges of all this hopeful listening, because the decades pass, and the instruments improve, and the surveys expand, and the data accumulates in enormous quantities, and through all of it, the result does not change. Silence. The galaxy, according to every instrument humanity has built and pointed at the sky, is completely and perfectly quiet. No confirmed artificial signal, no unambiguous transmission, no pattern that resists natural explanation. Millions of stars surveyed, billions of frequencies scanned, decades of patient, dedicated, well-funded scientific effort. Nothing. And this is where something subtle but important begins to happen inside the search. Because silence, when it persists long enough and across enough evidence, stops being a neutral observation. It becomes a fact that demands to be understood. It becomes a problem. The numbers say the universe should be alive with voices. The data says it is not. Something is sitting between those two statements, and it is not comfortable to look at directly. The search had always assumed that silence meant the instruments were not yet sensitive enough, that the surveys had not yet covered enough sky, that more time and more technology would eventually close the gap between expectation and observation. But by the early 21st century, that explanation is becoming harder to sustain. Breakthrough. Listen can detect signals of extraordinary faintness. The Kepler Space Telescope has confirmed that planets are not rare but universal. The James Webb Space Telescope can probe the atmospheres of worlds orbiting other stars. If signals exist, the tools to find them are now approaching the sensitivity required. And still, the universe holds its silence. The scientists keep listening. The programs keep running. The data keeps flowing in, processed by algorithms that search tirelessly for the pattern that would change everything. But something else is also happening quietly, in the background of all this patient work. A growing number of researchers, game theorists, philosophers, and strategic thinkers are beginning to ask a different kind of question. Not a technological question, not a question about instrument sensitivity or survey coverage or signal frequency. A deeper question. What if the silence is not a gap in the data? What if it is the data? What if the universe is not quiet because it is empty? What if it is quiet because something has made it that way? What if every civilization that has ever pointed instruments at the sky and asked the same question humanity is asking has eventually arrived at the same uncomfortable answer? That the safest thing you can do in a universe full of unknowns is not to listen. It is to make absolutely certain that no one can hear you. The stars outside your window are still burning, still silent, still holding whatever they know behind billions of years of patient darkness. And the question that began as wonder is slowly, gently becoming something else, not fear, something quieter than fear, something that feels like the first cool breath of a very old and very serious understanding. The universe is not empty. It is careful. You are still drifting. The darkness around you is total now. No city lights, no atmosphere to scatter the starlight into something softer. Just the raw, unfiltered universe in every direction. Stars burning at distances so vast that the light reaching you left its source before human civilization existed. And somewhere down there, on that small blue world, an astronomer is sitting in a quiet room, reviewing data printed on paper, when something stops him completely. He reaches for a red pen, he circles a number, and he writes a single word in the margin. Wow. The date is August 15th, 1977. The place is the Big Ear Radio Observatory at Ohio State University. The astronomer is Jerry Eman, a volunteer researcher who spends his evenings going through columns of computer-printed signal data, looking for anything that stands out from the natural background noise of the cosmos. What he finds that evening stands out in a way that nothing before or since has ever quite matched. The telescope has recorded a narrowband radio signal of extraordinary strength. It is centered almost perfectly on 1420 megahertz, the hydrogen frequency that SETI researchers have long predicted an intelligent civilization might use for interstellar communication. The signal is so cleanly defined, so precisely positioned, and so far above the background noise that it fits almost every criterion researchers had established for what an artificial extraterrestrial transmission might look like. It lasts exactly 72 seconds. This matches precisely the duration that a fixed point source in the sky would produce as Earth's rotation sweeps a radio telescope's beam across it. The signal comes from the direction of the constellation Sagittarius, from a region of sky containing no obvious natural source capable of producing something like this. Eman circles the data sequence and writes his now famous word in red ink. And then the signal is gone. In the years that follow, astronomers return to that region of sky hundreds of times, with Big Ear, then with instruments far more sensitive than Big Ear ever was. They listen across every frequency. They scan during every season. They watch from multiple telescopes simultaneously. The signal never returns. It appears exactly once. Perfectly consistent with what an artificial transmission might look like, and then it vanishes into the background noise of the universe as though it was never there. A 2017 study suggests the signal might have come from hydrogen emissions associated with comets passing through the telescope's beam. But other researchers push back, arguing that the signal's specific characteristics are inconsistent with a cometary origin. No natural explanation achieves universal agreement. No repetition is ever observed. The WOW signal remains, decades later, the strongest candidate detection in the entire history of the search, unexplained, unrepeated, and deeply, quietly haunting. But slowly, something else surfaces. 43 years after the WOW signal, in the spring of 2020, a different team of researchers makes a different kind of discovery. This one comes not from an old telescope on farmland in Ohio, but from Breakthrough Listen, the most sophisticated SETI program ever funded. They detect a narrowband radio signal. It is designated BLC1, and it appears to originate from the direction of Proxima Centauri, the closest star to our own Sun, sitting just 4.2 light-years away. The signal appears at 982 MHz, a frequency not commonly associated with known terrestrial sources, and not linked to any obvious natural astrophysical process. More intriguingly, it shows a slight frequency drift, the kind of drift you would expect from a transmitter located on a planet or object moving relative to Earth. The kind of signature that SETI programs are specifically designed to detect. For months, the detection is analysed carefully and quietly behind closed doors. The scientific community holds its breath. Proxima Centauri is already known to host at least 2 exoplanets. One of them, Proxima Centauri b, orbits within the star's habitable zone, the zone where surface temperatures might allow liquid water to exist. The possibility that a deliberate signal has been detected from the nearest potentially habitable world to Earth is genuinely electrifying. This is not a star thousands of light years away. This is the closest star there is. If something is broadcasting from there, the implications are almost too large to hold in the mind at once. And then the analysis concludes. Published in early 2021, the findings determine that BLC1 is almost certainly a product of terrestrial radio interference, likely generated by electronic equipment near the telescope itself. The signal's characteristics, while superficially compelling, are ultimately consistent with a human-made source rather than an extraterrestrial one. The disappointment is real, but so is the instruction buried inside it. BLC1 demonstrates 2 things simultaneously. First, that existing instruments are already sensitive enough to detect faint narrowband signals from the direction of nearby stars. Second, that terrestrial interference can mimic the exact signatures CT researchers are looking for with unsettling precision. The brief period during which BLC1 might have been real reveals something important about how deeply both scientists and the general public want the answer to be yes. But there is one more story in this chapter, and it is perhaps the strangest of them all. In 2015, astronomers analysing data from the Kepler Space Telescope noticed something unusual in the light curve of a star designated KIC 846852, later nicknamed Tabby's star, after astronomer Tabitha Boyajian, who leads the study that brings it to attention. Stars dim slightly when planets pass in front of them. This is how the Kepler telescope detects exoplanets. It watches for the tiny regular dips in starlight caused by an orbiting world crossing between the star and the telescope. The dips are small, they are regular, they are predictable. Tabby's star does something completely different. Its brightness drops by as much as 22% at irregular intervals. No planet could cause a dimming that large. No known natural process explains the pattern cleanly. The dips are irregular in timing, irregular in depth, and irregular in shape. They do not look like anything astronomers have encountered before. And so, carefully, seriously, researchers begin to consider an extraordinary possibility. What if the dimming is caused by a structure, an enormous artificial construction partially surrounding the star, built to harvest its energy? A concept that theoretical physicists have called a Dyson sphere or a Dyson swarm. The idea that a sufficiently advanced civilization might build a shell or cloud of collectors around its home star to capture as much of its energy as possible. CT observations of Tabby's star begin immediately. Radio frequencies are monitored. Optical wavelengths are scanned for laser pulses. If something artificial is orbiting that star, perhaps it is also broadcasting. No artificial signals are found. Subsequent studies conclude that the irregular dimming is most likely caused by clouds of dust orbiting the star in uneven concentrations. A natural explanation, if a somewhat unusual one. The megastructure hypothesis quietly steps back, but the episode leaves something behind that is worth sitting with. It shows how willing, serious, careful, well-credentialed scientists are to investigate even the most extraordinary possibilities when the data seems to point toward them. It shows how hungry the scientific community is for evidence that someone else is out there. Each of these moments follows the same quiet emotional pattern. Hope rises. A signal appears, strange and compelling, and almost perfectly consistent with what something artificial might look like. Analysis begins. Weeks or months pass in careful, methodical examination, and then the explanation arrives. Natural interference, terrestrial noise, dust clouds, comets. The door opens just slightly, and then it closes again. The wow signal, BLC1, Tabby's star, each one a moment where the universe seemed about to answer, and then thought better of it. Each one leaving humanity exactly where it began, listening, waiting, holding instruments up to a sky that gives nothing definitive back. And in the space between each of these almost moments, the silence grows more conspicuous rather than less. Because with every new instrument, every new survey, every new near miss, the argument that the universe is simply too primitive or too distant to have produced detectable signals becomes harder to maintain. The technology is there, the sensitivity is there, the coverage is expanding every year, and the silence remains. Not empty silence, not the silence of a universe that has nothing to say, but something that begins to feel more deliberate than accidental, more chosen than inevitable, like the silence of a forest at night when something moves through it. When every creature that can go still, goes still. You keep drifting, the stars keep burning, and the question that began as wonder and became a search is slowly becoming something else entirely. Something that asks not whether the universe is empty, but whether the universe has learned something that we have not yet understood. You're still drifting. The darkness stretches in every direction now, vast and patient and full of something you cannot quite name. And slowly something begins to shift in the nature of what you are observing. Because while the silence continues, the universe itself is revealing something extraordinary. It is revealing that Earth is not special, not in the way humanity once believed. For most of human history, planets were thought to be rare, perhaps even unique to our solar system. The idea that other stars might host their own worlds was philosophical speculation rather than scientific fact. Beautiful to imagine, but impossible to prove. And then, in 1995, everything changed. Astronomers Michel Mayor and Didier Queloz detected the first confirmed planet orbiting a sun-like star beyond our solar system. The planet was called 51 Pegasi b, a massive gas giant orbiting so close to its star that its year lasted only 4 days. It was nothing like Earth, but it was proof that planets existed around other stars. Proof that our solar system was not alone in hosting worlds. And once the first one was found, the floodgates opened. The Kepler Space Telescope launched in 2009 with a single mission: to stare at one patch of sky containing over 150,000 stars and watch for the tiny dips in brightness caused when planets cross in front of their host stars. The technique is called the transit method, and it works beautifully. Kepler discovered more than 2,700 confirmed exoplanets during its operational lifetime. It identified thousands more candidates awaiting confirmation. And from that data, astronomers were able to make a profound extrapolation. Nearly every star in the galaxy hosts at least one planet. Planets are not rare, they're universal. The Milky Way contains somewhere between 200 and 400 billion stars, which means it likely contains hundreds of billions of planets, perhaps more than 1 trillion worlds scattered across the vastness of the galaxy, and many of those worlds orbit in what astronomers call the habitable zone, the region around a star where temperatures might allow liquid water to exist on a planet's surface, the place where life as we understand it could potentially take root. one of the most remarkable discoveries came in 2017. Astronomers announced the TRAPPIST-1 system, located approximately 40 light-years from Earth. This system contains 7 rocky planets orbiting a single small red dwarf star. At least 3 of those planets orbit within the habitable zone. 7 worlds in one system, 3 of them potentially capable of supporting life. The discovery is stunning, not because TRAPPIST-1 is unique, but because it suggests systems like this might be common. That small dim stars, which vastly outnumber Sun-like stars in the galaxy, might host entire families of temperate rocky worlds packed close together in tight orbits. TRAPPIST-1 becomes a prime target for the next generation of instruments. Scientists want to study the atmospheres of those planets, to search for water vapor, to look for chemical signatures that might indicate biological activity, and the instrument capable of doing that is already in orbit. The James Webb Space Telescope begins operations in 2022. It is the most powerful space telescope ever built, and unlike previous instruments, it is designed specifically to probe the atmospheres of distant exoplanets. JWST can analyze the light passing through a planet's atmosphere as it crosses in front of its star. That light carries information. It reveals what molecules are present in the air: oxygen, methane, carbon dioxide, water, and potentially more complex molecules that do not occur naturally but might be produced by living organisms or technological civilizations. Early results are cautious but compelling. The telescope detects strong evidence of an atmosphere on the rocky exoplanet 55 Cancri E. It identifies intriguing chemical signatures on several other worlds, and in 2023, researchers report the possible detection of dimethyl sulfide in the atmosphere of K218b, a sub-Neptune exoplanet roughly 120 light-years away. On Earth, dimethyl sulfide is produced exclusively by living organisms, specifically by phytoplankton in the oceans. Its detection on another world is not proof of life. Natural processes we do not yet understand might produce the same molecule, but it demonstrates something profound. The technology to search for biosignatures, chemical evidence of life on distant worlds, is no longer hypothetical. It is operational. It is being used, and it is beginning to produce results. But slowly, something begins to settle over all of this extraordinary progress, because the picture that emerges from the exoplanet revolution is not one of scarcity. It is one of overwhelming abundance. Planets are everywhere. Habitable zones are common. The building blocks of life, carbon, hydrogen, oxygen, nitrogen, are universal. Organic molecules have been detected in interstellar clouds, on asteroids, on comets, and in the atmospheres of moons within our own solar system. The universe is not stingy with the ingredients required for life. It is generous with them almost to the point of extravagance. And yet, the silence continues. Not a single confirmed technosignature. No artificial radio emissions from the direction of any exoplanet. No laser pulses. No megastructures dimming distant stars in ways that resist natural explanation. No evidence that any of those billions of potentially habitable worlds has produced anything that looks back at us and says, "We are here." The numbers scream that we should not be alone. The data whispers that we are. This is where the Fermi Paradox gains its full weight. The galaxy is 13.6 billion years old. Our solar system formed only 4.6 billion years ago. That means the galaxy existed for 9 billion years before Earth even coalesced from its cloud of gas and dust. Stars significantly older than our Sun had billions of additional years for planets to form, cool, develop oceans, and perhaps give rise to life. Even using extraordinarily conservative estimates for the speed of interstellar expansion, A single determined civilization could have reached every habitable star system in the galaxy within tens of millions of years. That sounds impossibly long from a human perspective, but it represents less than 1% of the galaxy's total age. The galaxy has had enough time for this to happen not once, not twice, but hundreds of times over. And yet when we look at the cosmos with every instrument we possess, we see no evidence that it has ever happened. No Dyson spheres harvesting the energy of distant suns. No chemical signatures of industrial-scale engineering in exoplanet atmospheres. No self-replicating probes arriving in our solar system. No laser beacons cutting through the electromagnetic noise. Nothing that says unambiguously, someone was here, someone built this, someone is broadcasting. The silence is not subtle. It is not a matter of insufficient data or limited instruments. It is profound, systematic, and growing more conspicuous with every discovery that confirms how common the preconditions for life actually are. Scientists have proposed dozens of explanations over the decades. Perhaps intelligent life is genuinely rare. Perhaps the leap from simple biology to technological civilization requires such an improbable chain of events that Earth is one of very few worlds where it has happened. This is called the rare Earth hypothesis. Perhaps civilizations inevitably destroy themselves before becoming spacefaring. Nuclear weapons, climate collapse, engineered pathogens, runaway artificial intelligence. The list of existential threats is long. This is the great filter, a hypothetical barrier that very few civilizations manage to survive. Perhaps alien civilizations exist but communicate using methods we have not thought to monitor. Perhaps they exist in forms so different from our expectations that we would not recognize their technology even if we were looking directly at it. Perhaps they are deliberately avoiding us, treating Earth as a nature preserve. This is called the zoo hypothesis. Each explanation addresses part of the paradox. None resolves it completely. And then there is another category of explanation entirely, one that does not begin with the assumption that the galaxy is empty, one that begins with the opposite assumption. What if the galaxy is full of civilizations? What if life is common, intelligence is frequent, and technological species arise on countless worlds across billions of years? What if the numbers are right, and the universe has produced millions of minds capable of reaching across the stars? And what if every single one of them has independently learned the same lesson? That in a universe where trust is impossible and ignorance is lethal, the safest strategy is not to reach out, not to explore, not to communicate, but to hide. This is where the framework shifts from mystery to something colder, something more calculated. Because if silence is not a gap in the data but a behavior, then every unanswered signal, every empty frequency, every dark sky is not evidence of absence. Wait, it is evidence of discipline. The universe is full of worlds, the chemistry is universal, the timescales are vast, and the instruments we have built are finely sensitive enough to detect the kinds of signals a technological civilization might produce. The fact that we detect nothing is no longer easily dismissed as bad luck or insufficient technology. It is becoming a pattern, and patterns demand interpretation. What if the silence is not loneliness? What if the silence is strategy? What if every star you see burning in the night sky is a campfire around which someone sits, watching the darkness, trying desperately not to be seen? The universe has revealed its abundance, trillions of worlds, billions of habitable zones, and chemistry repeated endlessly across the spiraling arms of galaxies. Everything required for life exists everywhere, and yet the one thing missing is the thing we most expected to find: a voice, an answer, evidence that someone else looked up, wondered, built instruments, and reached out into the dark. The exoplanet revolution has given us the map. It has shown us where to look. It has confirmed that the destinations exist. But it has not explained why every destination appears to be silent. And that silence, growing heavier with every telescope and every survey, is beginning to suggest something uncomfortable. Not that we are alone, but that we are not listening carefully enough to what the silence is actually trying to tell us. The stars outside are patient, ancient, burning through hydrogen that has existed since the first moments after the universe began. And you notice something about them now, something that begins to settle uncomfortably in your awareness. They're old enough, they have been burning long enough, and around many of them, worlds have been circling for billions of years longer than Earth has existed. Which means that if intelligence arises naturally from the right conditions, then somewhere out there it should have already happened. Not once, not twice, but thousands of times, millions of times perhaps. And if even a single one of those civilizations had decided to expand outward, to spread across the stars, to leave evidence of its presence in the structure of the galaxy itself, we should see it. We should see something, but we see nothing, and that absence has a name. The year is 1950, summer. A group of physicists gathers for lunch at Los Alamos National Laboratory in New Mexico. The conversation turns, as it sometimes does among scientists, to recent reports of UFO sightings. The discussion is light-hearted at first, speculative, not entirely serious, and then one of the physicists, a man named Enrico Fermi, goes quiet for a moment. He has been doing calculations in his head, rough estimates, back-of-the-envelope arithmetic about the age of the galaxy, the number of stars, the likelihood of planets, and the feasibility of interstellar travel even at conservative speeds. And then he turns to his colleagues and asks a question that has haunted science ever since. Where is everybody? It sounds almost casual, almost dismissive. But embedded inside that simple question is a devastating paradox, and Fermi knew it. The Milky Way galaxy is approximately 13.6 billion years old. Our solar system formed 4.6 billion years ago, which means the galaxy existed for 9 billion years before Earth even began to coalesce. 9 billion years during which stars formed, planets cooled, and the conditions for life could have emerged on countless worlds. Stars older than our Sun have had billions of additional years for life to develop, for intelligence to emerge, for technology to advance, for civilizations to look outward and ask the same question we're asking now. And even if interstellar travel is difficult, even if it requires technologies far beyond anything humanity currently possesses, the timescales involved are so enormous that slow expansion would still be enough. Imagine a civilization that develops the capability to send colonists to a nearby star system, not at the speed of light, not even at a significant fraction of light speed, just 1% of the speed of light. Slow by cosmic standards, but achievable with technologies that do not violate known physics. At that speed, a journey to the nearest star would take roughly 400 years. A long time by human standards, but not impossible, not unthinkable. Generation ships. Suspended animation. Technologies we can already imagine even if we cannot yet build them. Now imagine that once the colony is established it waits. Perhaps 1,000 years, perhaps 10,000, time enough to build infrastructure, to grow a stable population, and then it sends out its own colony ships to the next set of nearby stars. Even with these extraordinarily conservative assumptions, long pauses between settlements and slow travel speeds, a single civilization could reach every habitable star system in the Milky Way within a few tens of millions of years. Tens of millions of years sounds vast, but it represents less than 1% of the galaxy's total age. The galaxy has had time for this to happen hundreds of times over, And yet when we look outward with our most powerful telescopes, when we scan the electromagnetic spectrum, when we analyse the light from distant stars and the atmospheres of exoplanets, we find no evidence that any civilization has ever done this. No megastructures, no engineered planets, no industrial chemical signatures in atmospheres that should be pristine, no self-replicating probes exploring our solar system, no radio beacons broadcasting across the galaxy, no optical signals pulsing in patterns that natural processes cannot explain. Nothing. The galaxy appears untouched, uncolonized, silent. This is the Fermi Paradox. Not a single mystery, but a collision between two observations that should not both be true. The universe has had more than enough time for intelligence to spread across the stars, and yet there is no evidence that it has. Something is preventing the expected outcome. Scientists have proposed solutions, many solutions, some optimistic, some deeply unsettling. Perhaps intelligent life is genuinely rare. Perhaps the chain of events required to go from simple chemistry to technological civilization is so improbable, so dependent on unlikely coincidences, that Earth is one of very few places where it has happened. This is the rare Earth hypothesis. It suggests that while simple life might be common, the leap to complex multicellular organisms requires specific conditions. A large moon to stabilize the planet's tilt, a gas giant in the outer system to deflect asteroids, there's plate tectonics to recycle nutrients, the right kind of star at the right distance from dangerous regions of the galaxy. Perhaps Earth won the cosmic lottery. Perhaps we are not special because we are chosen, but because we are statistically improbable. But there is another possibility, one that does not require life to be rare at all. Perhaps civilizations arise frequently. Perhaps intelligence is common. Perhaps thousands of species across the galaxy have developed technology, looked outward, and wondered if they were alone. And perhaps they all destroyed themselves before they could reach the stars. This is the concept of the Great Filter, a barrier so dangerous, so difficult to survive, that very few civilizations, if any, manage to pass through it. Nuclear war, ecological collapse, engineered pandemics, runaway artificial intelligence, resource depletion. The list of ways a technological civilization might annihilate itself is long and sobering. If the filter lies in our past, perhaps in the unlikely origin of life itself, then humanity has already survived the most dangerous step. We are rare, but safe. But if the filter lies ahead of us, then our future may be far shorter than we imagine. Every year we survive without self-destruction is another year closer to the barrier that stops everyone else. Still others suggest that civilizations exist, but remain undetectable for reasons that have nothing to do with rarity or destruction. Perhaps they communicate using methods we have not imagined. Perhaps they exist in forms so alien to our biology and cognition that we would not recognize their technology even if we saw it directly. Perhaps they live on timescales so different from ours that what we perceive as silence is simply the gap between their thoughts. Perhaps they are watching us deliberately, treating Earth as a preserve or an experiment, withholding contact until we reach some threshold of development. This is the zoo hypothesis. Plausible in some ways, but it raises its own problems. It requires coordination across potentially millions of civilizations. It requires agreement on a policy of silence. And it assumes that not a single civilization, across billions of years, has ever broken that agreement. Each of these explanations addresses part of the paradox. Each is logically defensible, but none feels entirely satisfying. None accounts cleanly for the sheer scale of the silence. And then there is one more category of solution, one that does not assume the galaxy is empty, one that does not require civilizations to be rare or self-destructive or fundamentally unknowable. It assumes the galaxy is full of life, full of intelligence, full of civilizations that have survived, thrived, and endured for millions of years longer than humanity has existed. And it asks a different question entirely. Not why we do not see anyone, but why no one wants to be seen. What if the silence is not a mystery to be solved? What if it is a behavior to be understood? Because there is a framework, built from game theory and strategic logic, that makes the Fermi Paradox not a puzzle, but a prediction. A framework that takes the conditions of the universe, distance, communication delay, mutual opacity, technological uncertainty, and shows that under those conditions, silence is not puzzling. Silence is rational. This framework is called the dark forest theory. And what it suggests about the meaning of cosmic silence is not comforting. It is not hopeful. But it is disturbingly coherent. It suggests that every advanced civilization in the galaxy has independently arrived at the same conclusion. That in a universe where you cannot know who is listening, where you cannot verify intentions, where a neighbour today might become a threat tomorrow, and where the cost of being wrong is extinction, the only strategy that reliably ensures survival is one that does not require trust. Remain hidden. Stay silent. And if you detect another civilization before it detects you, you face a choice with no good answers. Fermi asked his question over lunch in 1950. Casual, almost offhand. But the question has not gone away. It has only grown heavier as our instruments have improved and our surveys have expanded. Where is everybody? Perhaps the answer is not that they are gone. Perhaps the answer is that they are here, watching, listening, calculating the same risks we are only beginning to understand. And they have learned, through logic or bitter experience, that the most dangerous thing a civilization can do is let anyone know where it lives. The stars keep burning. The silence keeps holding. And the question that began as curiosity is slowly becoming something that feels more like a warning. The question Fermi asked hangs in the darkness around you now, quiet and patient and impossible to ignore. Where is everybody? And slowly, gently, you begin to notice something about how humanity has chosen to answer that question. Not with caution, not with patience, not with silence, but with signals. Humanity did not only listen. We called out, we announced ourselves, we sent messages into the void, carrying our location, our biology, our mathematics, and our hope. And we did it with the unshakable belief that being heard was a good thing. The date is November 16th, 1974. The place is the Arecibo Radio Observatory in Puerto Rico, home to one of the largest and most powerful radio telescopes ever built. A group of scientists gathers around the massive dish, preparing to do something that has never been done before. They're going to transmit a message, not to another nation, not to another continent, but to the stars. The transmission lasts less than 3 minutes. It contains 1,679 binary digits, ones and zeros, arranged in a rectangular grid. When decoded properly, the message depicts a stick figure of a human being, the numbers 1 through 10, the atomic numbers of key elements in human DNA, a graphic representation of the double helix structure, a diagram of our solar system with Earth highlighted, and an image of the Arecibo telescope itself. The message is aimed at Messier 13, a dense cluster of roughly 300,000 stars located approximately 22,000 light-years from Earth. Even travelling at the speed of light, the signal will not arrive for 22,000 years. A reply, if one ever comes, would not reach Earth for another 22,000 years. The Arecibo message is more symbolic than practical, but symbolism matters. It is a declaration, a statement, an announcement to the cosmos that humanity is here. We are intelligent, we are technological, and we wish to be known. The act of sending that signal represents something deep in human nature, the longing to reach outward, to connect, to bridge the distance between ourselves and the unknown, to say into the darkness, "We exist, do you?" And the assumption underneath that act is simple and powerful, that being known is desirable, that contact with another intelligence would be one of the greatest moments in human history, that the universe rewards openness rather than silence. This assumption shaped everything that followed. 3 years later, in 1977, NASA launched the twin Voyager spacecraft. Their primary mission was to study the outer planets, Jupiter, Saturn, Uranus, and Neptune. But the mission planners knew that eventually, after the planetary flybys were complete, both spacecraft would leave the solar system entirely and drift into interstellar space. And so they decided to send a message with them. Each Voyager probe carries a golden record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. The records include spoken greetings in 55 languages, music from cultures around the world, Beethoven, Chuck Berry, other traditional songs from China, India, Peru, and elsewhere, natural sounds like thunder, wind, bird calls, and the songs of humpback whales, and 116 images depicting human anatomy, architecture, landscapes, and scientific diagrams. Critically, each golden record also includes a pulsar map, a diagram showing the position of our Sun relative to 14 pulsars, rapidly spinning neutron stars that emit regular pulses of radiation. The map provides any finder with a precise cosmic address, a way to locate the origin of the spacecraft with extraordinary accuracy. The cover of each record displays instructions for playback, etched in symbolic language designed to be understandable by an intelligent species with no knowledge of human conventions. Carl Sagan, who chaired the committee that designed the records, described them as a message in a bottle cast into the cosmic ocean. The gesture was romantic, hopeful, and entirely consistent with the belief that contact with alien intelligence would be meaningful and transformative for both parties. Even if the chances of the records ever being found are vanishingly small, the act of creating them said something important about who humanity believed itself to be. A species that reaches outward, a species that hopes to be understood. But slowly, something shifts in the nature of what we are doing, because the Voyager records, beautiful as they are, drift outward passively. They do not announce themselves, they do not broadcast, they simply exist, waiting to be found by someone who happens to cross their path billions of years from now. Active messaging is different. Active messaging sends powerful, deliberate signals directly towards specific stars, and humanity has done this repeatedly. In 1999 and 2003, a series of transmissions called Cosmic Call were sent from the Evpatoria planetary radar in Crimea. These messages were aimed at multiple Sun-like stars within roughly 70 light-years of Earth. The radar, originally built for planetary research and missile detection, produced transmission power of approximately 150 kilowatts. When focused into a narrow beam, the effective radiated power was billions of watts, orders of magnitude more powerful than anything Earth leaks accidentally. In 2017, an organisation called METI International transmitted a message from Norway aimed at Lyten's star, a red dwarf approximately 12.4 light-years away. The star is known to host at least 2 exoplanets, one orbiting within the habitable zone. The transmission was deliberately designed to be detectable by a civilization with technology comparable to our own. The signal will arrive in the early 2030s. Each of these transmissions represents something qualitatively different from passive leakage. They are not accidental emissions that happen to escape into space. They are concentrated beams of energy carrying encoded information pointed at specific targets, designed explicitly to announce our existence and location to anyone capable of receiving them. And they were sent without international consensus, without global debate, without any formal mechanism for deciding whether humanity as a species consents to revealing itself to the cosmos. The Arecibo message was transmitted by a small team of astronomers. The cosmic call transmissions were organized by a private group. METI International operates as a non-profit with no accountability to any government or international body. A handful of people made a decision that could affect the long-term survival of every human being alive and every human being who will ever live. The logic behind these transmissions rests on several assumptions. The most important is this: any civilization advanced enough to detect our signals would be advanced enough to be peaceful. The reasoning goes that survival over millions of years requires cooperation, stability, and wisdom. A species capable of lasting that long would have evolved beyond the kind of reckless aggression that characterizes younger civilizations. Jill Tarter, one of SETI's most respected researchers, argued publicly that truly advanced civilizations would have moved beyond territorial violence. Douglas Vakoch, president of METI International, contended that the ability to interpret an interstellar message requires such sophisticated social development that any civilization capable of receiving it would almost certainly be open to peaceful exchange. The logic is comforting, and it is widely accepted. But not everyone shares this confidence. David Brin, an astrophysicist and science fiction author, has been one of the most vocal critics of active messaging for decades. He argues that no small group should have the authority to transmit signals on behalf of the entire human species without broad international consultation and consent. His objection is not that aliens are necessarily hostile. His objection is that the decision to announce humanity's location is irreversible and carries consequences that would affect everyone. Therefore, it should not be made unilaterally by enthusiasts operating without oversight. Brin challenges the core assumptions of METI advocates. He points out that intelligence does not predict benevolence. Dolphins are intelligent and generally peaceful. Chimpanzees are intelligent and frequently violent. Humans are the most intelligent species on Earth, and our history is soaked in blood. Projecting human hopes onto alien minds, he argues, is wishful thinking, not science. Stephen Hawking made similar arguments. In 2010, he drew an explicit parallel between potential alien contact and European colonization of the Americas. When technologically advanced civilizations encountered less developed ones on Earth, the outcome was almost always catastrophic for the weaker party. The indigenous peoples were not destroyed because the colonizers were uniquely evil. They were destroyed because the power imbalance was so extreme that intentions mattered less than capabilities. Hawking argued that any alien civilization capable of reaching Earth would possess technology so far beyond ours that we would have no way of defending ourselves, and no reliable way of distinguishing hostile intentions from benign ones before it was too late. He supported listening, but he explicitly warned against transmitting. The debate continues, but the signals are already gone, travelling outward at the speed of light, carrying our coordinates, our level of technology, our willingness to be seen. They cannot be recalled. They cannot be jammed. They cannot be taken back. Whatever consequences follow, they will follow for everyone. Not just for the scientists who press the button, but for the entire species, for every child born after the signals were sent, for civilizations of humans who may exist thousands of years from now, inheriting decisions they had no part in making. The dream of contact shaped those decisions, the belief that the universe is fundamentally kind. that advanced civilizations are wise and benevolent. That being known is better than remaining hidden. But there is another framework, one built not on hope, but on logic, one that asks what rational civilizations would do in a universe where trust is impossible and ignorance is lethal. And what that framework suggests is not comforting. It suggests that every signal we have sent may have been the most dangerous thing our species has ever done. The signals humanity sent are travelling outward now, beyond recall, carrying our location into the dark. And somewhere in the silence that surrounds you, a different kind of question begins to form. Not a question about what we hope to find, but a question about what the silence itself might mean. What if it is not emptiness? What if it is a warning? The theory that reframes everything did not emerge from a laboratory. It did not appear in a peer-reviewed journal or at a scientific conference. It came from a work of fiction. And yet it escaped the boundaries of storytelling almost immediately and entered serious scientific discourse, where it has remained ever since. In 2008, Chinese science fiction author Liu Cixin published a novel called The Dark Forest, the second volume of his Remembrance of Earth's Past trilogy. The book introduced a concept so clean, so logically rigorous, and so resistant to comfortable counter-arguments that it demanded engagement even from researchers who found its conclusion disturbing. The concept is framed as a discovery made by a character who derives the logic of cosmic survival from basic principles, the way a mathematician might prove a theorem. The reasoning is airtight within its assumptions. The conclusion is devastating, and the most unsettling part is this. The logic does not require aliens to be cruel. It requires only that they be rational. The theory begins with two axioms, simple statements that almost any biologist, economist, or evolutionary theorist would accept without argument. The first axiom: survival is the primary need of every civilization. This does not mean civilizations care only about survival. It means survival is the foundation for everything else. A civilization that ceases to exist cannot pursue knowledge, create art, explore the universe, or fulfill any other purpose. Whatever a civilization values, it must first continue to exist in order to value it. Every organism, every species, every society that has ever lived on Earth has operated under this principle. The drive to persist is the foundation on which all other drives are built. The second axiom: civilizations continuously grow and expand, but the total matter and energy in the universe remains constant. Again, this is observation, not speculation. Populations grow, resource consumption increases, yet territorial requirements expand. This does not mean every civilization expands through conquest. It means that over long enough timescales, a growing civilization will require more resources than its immediate environment provides, and the universe, despite its staggering size, contains a finite amount of matter and energy. These two axioms alone do not produce the dark conclusion. If the universe was small and fully transparent, civilizations could observe each other, assess intentions, negotiate agreements, and build cooperative relationships. But the universe is not small, and it is not transparent. The critical ingredients that transform reasonable axioms into something terrifying are two additional concepts: the chain of suspicion and the technological explosion. The chain of suspicion is rooted in a problem that game theorists have studied for decades, but never before at cosmic scale. When two civilizations become aware of each other across interstellar distances, neither can reliably determine the other's intentions. This is not a technical limitation that better technology could solve. It is structural. It arises from distance, communication delay, and the fundamental opacity of alien minds. Consider what happens when Civilization A detects Civilization B. The first question is whether B is hostile or peaceful. On Earth, nations can observe behavior, exchange ambassadors, build trade relationships, and gradually establish trust or mutual understanding. Messages travel in hours or days. Behavior can be monitored continuously. None of these conditions hold at interstellar scale. The nearest star, Proxima Centauri, is 4.2 light-years away. A radio message would take over 4 years to arrive. A reply would take another 4 years. A single exchange of greetings consumes nearly a decade. Meaningful negotiation could stretch across centuries. You cannot assess character through dialogue when each exchange takes decades. You cannot monitor behavior in real time when the light showing their current state left their world before your grandparents were born. You cannot enforce agreements when violations would not be detected for generations. But the chain of suspicion goes deeper. Even if two civilizations could communicate rapidly, they face a more fundamental problem. Neither can ever be certain of the other's true nature. Not just current intentions, but deepest motivations, evolutionary psychology, capacity for deception, and future trajectory. Between alien civilizations separated by light years and potentially billions of years of independent evolution, no common ground exists. The other civilization might think in ways that have no analogue in human experience. This is where the chain becomes recursive. Civilization A does not know whether civilization B is hostile. But even if A assumes B is peaceful, A cannot know whether B believes A is peaceful. And even if both are genuinely peaceful, A cannot know that B knows that A knows that B is peaceful. The uncertainty propagates infinitely. Each level of inference adds another layer of doubt. On Earth, we manage this through institutions, repeated interactions, and shared frameworks, international law, trade agreements, cultural exchange. But every one of these mechanisms depends on proximity, speed of communication, and the ability to verify and enforce agreements. Remove those conditions, and the chain of suspicion becomes unbreakable. The second concept, the technological explosion, makes the anxiety unbearable. On Earth, technological development has accelerated at rates previous generations could never have imagined. 200 years ago, the fastest communication was a horse-drawn courier. 100 years ago, radio was a novelty. 50 years ago, computers filled entire rooms. Today, smartphones exceed the computing power that sent humans to the moon. The interval between revolutions keeps shrinking. Now extend this to cosmic timescales. A civilization that is primitive today, perhaps in its industrial age, could undergo a technological explosion and develop interstellar travel or planet-destroying weapons within a few centuries. A few centuries is nothing in cosmic terms. It is a rounding error in the life of a star, an eye blink in galactic history. This means no civilization, however advanced, can safely assume a less developed neighbor will remain harmless. The gap between primitive and dangerous can close within a time frame so short it barely registers astronomically. Human history proves the point. In 1900, powered flight did not exist. By 1969, humans walked on the moon. By the late 20th century, we possessed nuclear arsenals capable of rendering the planet uninhabitable. From the perspective of any civilization watching from even a modest distance, Earth transformed from harmless to potentially lethal within a communication delay. This is the nightmare the technological explosion introduces. It is not enough to assess whether another civilization is currently dangerous. You must assess whether it could become dangerous within a cosmically insignificant period, and the answer is almost always yes. Combine the chain of suspicion with the technological explosion, and the strategic landscape becomes extraordinarily bleak. You have detected another civilization. You cannot determine its intentions. You cannot communicate fast enough to build trust. even if it appears harmless now, is just technological development could transform it into an existential threat within decades or centuries. You cannot verify promises, you cannot enforce agreements, and you know the other civilization is performing exactly the same calculation about you. This is the game-theoretic structure the dark forest theory identifies as the fundamental condition of interstellar relations. It resembles the prisoner's dilemma, but with features that make cooperation far harder. The interactions are not repeated. The stakes are existential. There is no enforcement mechanism. Each civilization operates in a strategic vacuum, making decisions with permanent consequences based on information it can never fully observe. Under these constraints, the game-theoretic equilibrium is grim. The only strategy that reliably ensures survival is one that does not require trust. Remain hidden, and if you detect another civilization before it detects you, eliminate it before it can pose a threat. Not because you are evil, not because you enjoy destruction, not because you have assessed the other civilization and determined it to be hostile, but because the structure of the situation makes any other choice a gamble with your civilization's existence, and the cost of losing that gamble is infinite. This is the dark forest. The metaphor is precise. Imagine a vast forest at night. You are a hunter moving through the trees. You know other hunters are out there, but you cannot see them. You do not know how many, where they are, or what weapons they carry. You cannot call out because your voice would reveal your position to every hunter in the forest. Some might be friendly, but some might shoot at any sound they hear, and you have no way of telling which is which before you reveal yourself. The rational strategy is to move silently, remain invisible, and if you spot another hunter before they spot you, make a decision while you still have the advantage of surprise. Now scale this to a galaxy containing billions of stars, potentially millions of civilizations, and timescales measured in billions of years. The forest is 100,000 light-years across. The hunters are civilizations that endure for millennia, and the stakes are not personal survival, but the survival of entire species, entire biospheres, entire histories of art, science, and consciousness. In this forest, every civilization faces the same dilemma. Broadcasting reveals your location to everyone within range. Some may be benign, but you cannot determine which, and you cannot afford to be wrong. The cost of being wrong is not embarrassment. It is extinction, and extinction is permanent. The theory predicts a specific observable behavior, universal silence. Every civilization that survives long enough to understand the strategic landscape will independently converge on the same conclusion. Hide. Do not transmit. Do not respond. If you detect a civilization that has revealed its position, you face a choice the theory suggests may have only one survivable answer. This creates an ecosystem of silence, not enforced by tyranny, but selected by logic. Civilizations that broadcast are exposed. Civilizations that remain hidden persist. Over billions of years, the galaxy becomes populated overwhelmingly by those who learned the first rule of cosmic survival: never let anyone know you exist. The theory does not claim all aliens are hostile. It claims you cannot know whether they are, and that uncertainty itself is the danger. It does not require malice. It requires only mathematics. Distance makes communication impractical. The chain of suspicion makes trust impossible. The technological explosion makes even weak neighbours potentially dangerous. And the absence of enforcement means cooperation cannot be guaranteed. The silence we observe is not emptiness, it is discipline. And the most dangerous thing humanity has done may not be failing to find aliens, it may be letting them find us. And now the silence around you has taken on a different quality. It is no longer empty, it is no longer neutral. It has become something with weight, something with intention, something that seems to be communicating even through its refusal to communicate. And slowly, carefully, you begin to understand why. Imagine a moment of first contact, not in the way humanity has always imagined it, not ships descending from the sky, not diplomatic meetings, but something quieter and more distant. Your civilization has just detected unmistakable evidence of another technological species. Perhaps you have intercepted a targeted radio transmission, a narrowband signal carrying encoded information from a star system 80 light-years away. The signal is unambiguously artificial, or no natural process could produce it. You now know with certainty that another civilization exists. You know approximately where it is located. The question is what to do with this knowledge. Your first option is to respond. You could transmit a message back, introducing yourself, sharing scientific knowledge, proposing peaceful exchange. This feels natural to a species like humanity, raised on stories of contact and cooperation. But consider what responding actually costs you. By transmitting a reply, you confirm your own existence and reveal your own location to the civilization that sent the original signal. More than that, you reveal your location to every other civilization within range of your reply, civilizations you may not know about, civilizations whose existence the original senders may not know about either. Your reply does not travel only to its intended recipient. It radiates outward in all directions, announcing your position to the entire surrounding volume of space, and you have no way of knowing who else is listening. Furthermore, your reply will not arrive at its destination for 80 years. A response to your reply will not reach you for another 80 years. A single exchange of greetings consumes 160 years. Meaningful negotiation would span centuries or millennia. During that entire period, you know nothing about how the other civilization is developing, what strategic decisions it's making, or whether its intentions have changed. You are conducting diplomacy across a communication gap so vast that entire political systems could rise and collapse between messages. Your second option is to remain silent and observe. You could watch the other civilization from a distance, gathering information without revealing yourself. This is safer than responding. But it introduces its own risks. You do not know whether the other civilization has already detected you through your own leaked emissions or previous transmissions. You do not know whether a third civilization has detected both of you and is making its own calculations. And you are aware that every year you spend observing is a year in which the other civilization continues to develop technologically. If it is currently less advanced than you, the gap may close. If it is more advanced, you learn nothing from observation that would help you in a confrontation. Time does not necessarily work in your favor. Your third option is preemptive action. You could attempt to eliminate the other civilization before it can pose a threat. This is the option that most people instinctively recoil from. It requires destroying an entire civilization, entire worlds, entire species, based on the mere possibility that it might someday become dangerous. Not on evidence that it has hostile intentions, not on any act of aggression, but purely on the logic that you cannot afford to be wrong. It is monstrous by any human moral standard. And yet the dark forest theory argues that the structure of the situation makes it the only option that does not require gambling your civilization's existence on assumptions you cannot verify. Notice what has happened in this decision tree. Every path that involves communication, cooperation, or trust requires you to make assumptions about the other civilization that you have no way of verifying. Every path that involves patience requires you to accept increasing risk as the other civilization develops. Only the path that eliminates the unknown variable removes the uncertainty entirely. The logic does not reward openness. It does not reward curiosity. It does not reward the qualities humanity considers its highest virtues. It rewards only the willingness to act decisively on incomplete information in a situation where the cost of hesitation might be measured in billions of lives. The chain of suspicion is the mechanism that makes this logic feel inescapable. It is rooted in something fundamental about the structure of the cosmic environment. Information travels at the speed of light. Distance is incomprehensibly vast. Communication delays are measured in years, decades, and centuries. This creates a situation where no civilization can ever achieve reliable knowledge of another civilization's true nature or intentions. The other civilization might be peaceful, but you cannot know that with certainty. The other civilization might claim to be peaceful, but peaceful civilizations claim to be peaceful. Hostile civilizations also claim to be peaceful if it serves their interests. In game theory, a signal is informative only if it is costly to fake. On Earth, diplomatic signals like troop withdrawals or arms reductions carry some weight, because they impose real costs on the signaling party. But in the cosmic context, a message professing peaceful intentions costs nothing to produce, and is trivially easy for a hostile civilization to imitate. There is no way for a receiving civilization to distinguish a genuine peace signal from a deceptive one. This creates what game theorists call a pooling equilibrium. All types of senders, peaceful and hostile alike, produce identical signals. When all signals look the same, the signals become informationally worthless. The result is that transmitting a message into space, no matter how carefully crafted, cannot reduce strategic uncertainty. It can only increase danger to the sender by confirming their existence and location. The message accomplishes the opposite of its intended purpose. Instead of building trust, it provides targeting information. But the chain of suspicion extends even deeper than this. Consider the recursive problem. Civilization A sends a signal. Civilization B receives it. B now knows A exists, but what does B know about what A knows? B does not know whether A realizes that A's signal might be detected by other civilizations besides B. B does not know whether A has considered the possibility that detecting A's signal implies as willingness to be detected, and which might mean A is either naive or dangerously powerful. Each of these interpretations changes the strategic calculation. A naive civilization is vulnerable. A powerful civilization is threatening. Either way, B's assessment of A shapes B's decision about how to respond, and A, having sent the signal, cannot control how B interprets it. A cannot explain its reasoning. A cannot correct misunderstandings, because any attempt to clarify would just be another signal, which would take decades to arrive, by which time B may have already acted on its initial assessment. This infinite regression of uncertainty is the chain of suspicion, and it cannot be broken by any finite number of messages, promises, or demonstrations of goodwill. On Earth, we manage these recursive uncertainties through institutions, repeated interactions, and shared frameworks of meaning. International law, trade agreements, cultural exchange, diplomatic norms. These are all mechanisms for collapsing chains of suspicion into manageable levels of uncertainty. But every single one of these mechanisms depends on proximity, speed of communication, shared context, and the ability to verify and enforce agreements. Remove those conditions, and the chain of suspicion becomes unbreakable. A civilization facing this chain has only a limited set of options, and none of them are comfortable. It can attempt communication and hope that the other party responds peacefully, accepting the risk that it might not. It can remain silent and hope that it has not already been detected. Or it can take preemptive action to eliminate the potential threat before the other civilization has a chance to act. Each option carries enormous risk, but the chain of suspicion ensures that none of them can be pursued with confidence. It creates a persistent, irreducible anxiety, that shapes all strategic thinking about interstellar relations. And it makes one thing unavoidably clear. In a universe where trust cannot be verified, where intentions cannot be confirmed, where communication is too slow to matter, and violations cannot be detected in time to respond, the rational actor does not gamble. The rational actor acts decisively to eliminate uncertainty, regardless of what that requires. This is not speculation about alien psychology. This is mathematics applied to an environment where the rules are written by physics itself. Distance, delay, opacity, uncertainty. These are not assumptions. They are facts about the universe we inhabit. And they make one conclusion almost inescapable. In such a universe, silence is not a puzzle. Silence is strategy. Silence is rationality. Silence is survival. The signals humanity has sent are travelling outward into this universe now, announcing our existence, revealing our location, broadcasting our willingness to be found. And the question that the chain of suspicion raises is simple and devastating. What happens when they arrive? The chain of suspicion has settled around you now like a weight, and you begin to understand something about time itself, how it moves differently when you are separated by light years, how a century becomes nothing, how 1,000 years is a blink, how the future of a civilization can change beyond recognition, in what amounts to a cosmic instant. And you understand why that matters, because there is one more piece to the puzzle, one more mechanism that transforms the chain of suspicion. From difficult into nearly inescapable, it is the speed at which everything changes. On Earth, technological development has accelerated, at rates that previous generations would have found impossible to imagine. 200 years ago, the fastest way to send a message across a country was a horse-drawn courier, a journey that took weeks. 100 years ago, radio was a scientific novelty. 50 years ago, computers filled entire rooms and had less processing power than a modern wristwatch. 20 years ago, smartphones did not exist. The interval between major technological revolutions has been shrinking consistently, and each revolution brings capabilities that the previous generation could not have predicted. Now extend this observation to cosmic timescales. A civilization that is technologically primitive today, perhaps in its equivalent of Earth's industrial age, could undergo a technological explosion and develop interstellar travel, planet-destroying weapons, or self-replicating war machines within a few centuries. A few centuries sounds like an enormous stretch of time from a human perspective, but it is nothing in cosmic terms. It is a rounding error in the life of a star, an eye blink in the history of a galaxy. This means that no civilization, however advanced, can safely assume that a less developed neighbour will remain harmless indefinitely. Consider what this means for the strategic calculation. You have detected another civilization. It is currently less technologically advanced than you are, perhaps by centuries, perhaps by thousands of years. You might think you have time. You might believe the gap between your capabilities and theirs is so vast that you could afford to wait and see. But the technological explosion changes the equation entirely. The gap between primitive and dangerous is not permanent. It is not stable. It can close within a time frame so short that monitoring and responding becomes impossible. Within a time frame too short for the light speed delay of even a nearby signal to matter. Human history alone demonstrates the point with terrible clarity. In 1900, powered flight did not exist. By 1945, humanity had developed aircraft capable of dropping atomic bombs. By 1969, humans had walked on the moon. By the late 20th century, humanity possessed nuclear arsenals, capable of rendering the entire planet uninhabitable. Thousands of warheads, delivery systems that could reach anywhere on Earth within minutes. The capacity to end civilization as we knew it. From the perspective of any civilization. Watching from even a few hundred light years away, Earth transitioned from harmless to potentially lethal, in a span of time shorter than the round-trip communication delay between nearby stars. The implications are staggering. Even if a civilization is currently primitive, even if it poses no immediate threat, you cannot afford to ignore it. Because within a few centuries, within a few thousand years at most, it might develop the capacity to reach your worlds, to threaten your systems, to destroy everything you have built. This is the nightmare that the technological explosion introduces into the strategic calculus of the dark forest. It is not enough to assess whether another civilization is currently dangerous. You must assess whether it could become dangerous within a cosmically insignificant period. And the answer in almost every case is yes. Consider the decision facing an advanced civilization that detects a primitive one. The primitive civilization is currently harmless. It has not even left its home system. It has no weapons capable of reaching beyond its own world. By any rational assessment, it poses no immediate threat. But the advanced civilization knows something that the primitive one does not yet understand. It knows how fast things can change. It knows that intelligence tends to solve problems. It knows that problem solving leads to technological development. It knows that technological development accelerates. The advanced civilization does not need to observe for long. It does not need to gather extensive data. It simply needs to understand the trajectory. A species that has gone from powered flight to nuclear weapons in a single century is on a path toward becoming dangerous. And this is where the chain of suspicion meets the technological explosion, and the result is devastating. You cannot determine the other civilization's intentions. That is the chain of suspicion. But even if the other civilization is currently peaceful, you cannot afford to assume it will remain peaceful forever. Because technological development will transform its capabilities. And once those capabilities exist, intentions become secondary to what is possible. A peaceful civilization with planet-destroying weapons is still dangerous because accidents happen, miscalculations happen, political systems change. What is peaceful today might become aggressive tomorrow, and by then it will be too late to stop. The technological explosion ensures that the gap between safe and unsafe can close faster than any response mechanism can react. This creates a situation where waiting becomes increasingly risky. If you wait for the other civilization to become more advanced, you are waiting for it to become more dangerous. If you wait for confirmation of hostile intent, you might wait until hostility is already being acted upon. If you wait for some clear sign that action is necessary, that sign might be the first weapon launched against your worlds. The only option that mitigates the risk is action taken before the gap closes completely. Action taken while you still possess overwhelming advantage. Action taken based on what the other civilization might become, not what it currently is. But here is where the logic becomes almost inescapable. The civilization you are considering eliminating is not thinking in isolation. It is performing the exact same calculation about you. It is monitoring your development. It is assessing your trajectory. It is considering whether you might become dangerous in the future. And if both civilizations are rational, both will reach the same conclusion simultaneously. Both will decide that waiting is increasingly risky. Both will begin to consider whether preemptive action is justified. The result is a race to act first, not because either civilization is inherently aggressive, but because both are rational, and both understand the logic of the technological explosion. The technological explosion also reshapes what we might call the window of opportunity. An advanced civilization might have the capability to eliminate a primitive one, but that capability might not last forever. As the primitive civilization develops, eventually it might develop defenses. It might develop weapons of its own. The gap might narrow enough that an attack becomes costly or even impossible. This creates urgency. If you are going to act, you should act while the disparity is still overwhelming. Waiting means risking that the window closes before you can act. Waiting means accepting increasing probability that the other civilization will eventually pose a genuine threat. From a purely strategic perspective, the logical time to act is sooner rather than later, earlier rather than when civilizations are more evenly matched. This is the mechanism. That makes the dark forest logic almost inescapable. It is not driven by malice or aggression or conquest. It is driven by the simple fact that technological change is rapid and irreversible. Once a civilization develops certain capabilities, those capabilities persist. The weapons exist. The knowledge exists. The ability to use it exists. And in a universe where you cannot trust your neighbour, where you cannot verify their intentions, where you cannot enforce agreements, those capabilities represent risk. The technological explosion ensures that risk grows with time. It ensures that waiting becomes strategically worse the longer you delay. It ensures that rational actors performing the same calculation will reach the same conclusion. The stars outside are still burning. Civilization after civilization watching each other across light-year distances, performing calculations, assessing trajectories, understanding that the primitive civilization they see today might be the advanced threat of tomorrow. And somewhere in the balance, between the chain of suspicion and the technological explosion, decisions are made. Decisions that reshape the galaxy, decisions that ensure only those who learned the first rule of cosmic survival. Remain to see the next billion years. Remain hidden. Do not let them see you coming, because the moment they detect your presence is the moment they begin calculating whether you will eventually become a threat. And if they calculate fast enough, if they understand the implications of technological development, quickly enough, they might decide to act before you become dangerous. The race to silence is not started by aggression, it is started by rationality. Applied to a universe where time, distance and uncertainty combine to make trust impossible and caution essential. And now something shifts in your awareness, because all of this logic, all of this careful analysis of why civilizations remain silent, all of this understanding of why the chain of suspicion and the technological explosion make hiding the only rational strategy, it all becomes suddenly uncomfortably personal, because humanity has not remained silent. We have called out. We have announced ourselves. We have sent signals into the dark, with the confidence of a species that has never been answered and does not yet know what an answer might cost. The distinction between passive leakage and active transmission is not merely technical. Under dark forest logic, it is the difference between a faint rustling in the underbrush and a sustained shout echoing across the forest. Passive leakage began roughly a century ago, when commercial radio broadcasting emerged in the 1920s. Since then, Earth has been radiating electromagnetic energy in all directions, from radio transmitters, television stations, military radar installations, satellite communication systems, and an ever-growing array of digital technologies. This expanding sphere of radio emissions, sometimes called Earth's radio bubble, now extends outward approximately 100 light-years from our planet. In principle, any civilization within that radius, with sufficiently sensitive receiving equipment, could detect anomalous electromagnetic emissions coming from the direction of our Sun. This fact has led to what is commonly called the barn door argument, one of the most frequently cited justifications for active messaging programs. The argument is straightforward. The barn door is already open. We have been leaking signals for a century. Any sufficiently advanced civilization, within 100 light years, already knows we are here. Therefore, there is no additional risk in sending deliberate targeted transmissions we cannot hide. So we might as well speak clearly. The barn door argument is intuitive, widely repeated, and according to a significant number of scientists who have studied the question carefully, dangerously wrong. The problem lies in the physics of signal propagation across interstellar distances. Electromagnetic signals weaken. According to the inverse square law, every time the distance from the source doubles, the signal strength drops to 1/4. This means that Earth's leaked radio and television signals, which were never designed for interstellar communication, become extraordinarily faint within a remarkably short distance. A typical commercial radio station. Outputs measured in kilowatts. Military radar installations reach megawatts of peak power, but they are not omnidirectional and operate intermittently. By the time these signals have travelled even a few light years, they have spread across such an enormous volume of space that their energy density drops below the natural electromagnetic background noise of the galaxy. Cosmic radio sources, including pulsars, quasars, and the cosmic microwave background, all contribute to a noisy electromagnetic environment in which faint signals quickly become undetectable. Scientists have calculated what it would take for an alien civilization to detect Earth's leaked emissions from various distances. At a distance of just a few hundred light years, detecting a signal equivalent to a typical television broadcast would require a receiving antenna. With a collecting area measured in thousands of square kilometres, that is not physically impossible, but it represents an engineering commitment no civilization would undertake. Unless it already had strong reason to believe a signal was there, at distances of a few thousand light years, required antenna sizes become absurd. At galactic distances, Earth's leaked emissions are completely indistinguishable from the natural background. Furthermore, the nature of Earth's leaked signals has changed over decades in ways that make us harder, not easier, to detect. Early television and radio broadcasts used high-power analog transmissions. Modern communication technologies have shifted overwhelmingly toward digital formats, fiber optic cables, low-power cellular networks, and directional satellite transmissions. Earth is actually becoming quieter as our technology advances. The radio bubble is not growing louder, it is fading. This is the critical flaw in the barn door argument. Earth's passive leakage is not a shout. That has already revealed our position to the galaxy. It is a whisper. That becomes inaudible within a cosmically insignificant distance. Deliberate transmissions are an entirely different matter. The Arecibo message, transmitted in 1974, used the full power of the telescope's transmitter, approximately 450 kilowatts, focused into a narrow beam aimed at a specific target. The effective radiated power in the direction of that beam was on the order of trillions of watts, millions of times more powerful than a typical television broadcast. This enormous disparity between leaked signals and targeted transmissions is not a minor detail, it is the entire point. A directed high-power transmission is designed to be detectable across interstellar distances. That is its explicit purpose. Comparing it to Earth's passive leakage is like comparing a military searchlight to the glow of a firefly. The cosmic call transmissions of 1999 and 2003 used similar principles. Transmitted from the Yevpatoria planetary radar in Crimea, these messages were aimed at multiple Sun-like stars within approximately 70 light-years of Earth. When focused into a narrow beam, the effective radiated power was billions of watts, orders of magnitude above anything Earth's leaked emissions produce. In 2017, METI International transmitted a message from a facility in Norway targeted at Luton's star, a red dwarf approximately 12.4 light-years from Earth. The signal was deliberately designed to be detectable by a civilization with technology comparable to our own. The transmission will arrive at its destination in the early 2030s. Each of these transmissions represents a qualitative escalation beyond passive leakage. They are not accidental emissions, they are concentrated beams of energy, carrying encoded information pointed at specific targets, and intended to announce our existence and location to anyone capable of receiving them. And they were sent without international consensus, without global debate, without any formal mechanism for deciding whether humanity as a species consents to revealing itself to the cosmos. The debate surrounding these transmissions has been far more contentious than most people realize. David Brin, an astrophysicist, whose work on the Fermi Paradox helped establish the intellectual framework that the dark forest theory later built upon, has been one of the most vocal and persistent critics of active messaging programs. Brin has argued for decades that no individual scientist, no small organization, and no single nation should have the authority to transmit powerful signals on behalf of the entire human species without broad international consultation and consent. His objection is not that contact is impossible, or that all aliens are hostile. His objection is that the decision to announce humanity's existence and location to the cosmos is irreversible and carries consequences that would affect every person on Earth. Therefore, it should not be made unilaterally, by small groups operating without oversight. Brin has specifically challenged the rationalizations offered by METI advocates. He has debunked the barn door argument by pointing to the physics of signal attenuation. He has questioned the assumption that advanced civilizations would necessarily be peaceful, by noting that intelligence and benevolence do not correlate reliably. Stephen Hawking made similar arguments from an even more prominent platform. In 2010, he drew an explicit parallel between potential alien contact and European colonization of the Americas. When technologically advanced civilizations have encountered less developed ones on Earth, the outcome has almost always been catastrophic for the weaker party. Hawking argued that any alien civilization capable of reaching Earth would possess technology so far beyond our capabilities that we would have no way of defending ourselves and no reliable way of distinguishing hostile intentions from benign ones, he supported the SETI program's mission to listen. But he explicitly warned against transmitting, arguing that announcing our existence to the cosmos, without understanding who might be listening, was reckless beyond measure. The counter-arguments from METI proponents are significant. They argue that the potential benefits of contact with an advanced civilization, access to knowledge, technology, and perhaps solutions to existential problems, outweigh the speculative risks. They contend that any civilization, capable of interstellar action, would have no conceivable motivation. To harm a species as primitive as humanity, they argue that passive SETI listening is itself an implicit endorsement of active messaging, since detecting an alien signal would inevitably provoke chaotic responses from Earth anyway. These arguments have merit, but they do not address the core logic of the dark forest theory. The theory does not claim that aliens are definitely hostile. It claims that you cannot know whether they are hostile, and that this uncertainty itself is the danger. And yet here is the uncomfortable reality. The signals are already gone, travelling outward at the speed of light. They cannot be recalled. They cannot be jammed. They cannot be taken back. Whatever civilizations might detect them, whatever calculations those civilizations might make about Earth's location and technological level, whatever decisions might follow from those detections, they are now set in motion. The experiment has already been conducted. The only question remaining is what the result will be. You are still drifting, and the signals that humanity sent are drifting with you now, racing outward at light speed, carrying coordinates and evidence of technology, and proof of our willingness to be found. The barn door argument was wrong about the risk. The passive leakage was not the danger. The active transmissions are. And they are irreversible. We have called out. We have announced ourselves. We have done the thing that under dark forest logic might be the most dangerous thing any young civilization can do. And now we wait in the silence, hoping that no one answers, or hoping that if someone does, they answer with mercy rather than mathematics. The signals are out there now, travelling at the speed of light, crossing the distance between stars. And back on that small blue world below, a debate is unfolding, quiet in public, intense in private. A debate about whether humanity has made a terrible mistake, or whether the fear surrounding that mistake is itself the problem. It is a debate with no easy resolution. And the stakes could not be higher. The scientific community has never been unified. On the question of active messaging, from the very beginning, a persistent minority of researchers has raised uncomfortable questions about the wisdom of broadcasting into the dark. Their concerns were rarely given equal weight in public conversation, partly because the optimistic narrative of contact was so deeply embedded in the culture of the search, and partly because the objections felt abstract. In the absence of any evidence that anyone was actually listening, that the objections existed, and they rested on logic that was harder to refute than many enthusiastic proponents were willing to admit. David Brin has been raising this alarm longer than almost anyone. An astrophysicist, science fiction author, and serious thinker about the long-term future of civilization, Brin has argued for decades that the decision to transmit signals on behalf of humanity is fundamentally different from the decision to listen. Listening is passive. It costs nothing in terms of exposure. It reveals nothing about our location or capabilities. It is, by any rational assessment, safe. Transmitting is the opposite. Every deliberate transmission confirms our existence, reveals our location, demonstrates our level of technology, and announces our willingness to be found. Each of these pieces of information changes the strategic calculation. For any civilization that detects the signal, Brin's core argument is procedural, as much as it is strategic. No individual scientist, no small organization, and no single nation should have the authority to make this decision on behalf of the entire human species. The potential consequences of active messaging would be felt by everyone on Earth, not just the researchers who sent the signal, and therefore the decision should require broad international consultation and genuine consent. This is not a hypothetical concern. The Arecibo message of 1974 was transmitted by a small team of astronomers without authorization from any governmental body. No nation approved it. No international organization sanctioned it. A handful of scientists decided, on the basis of their own judgment, that humanity should announce itself to the cosmos. And they did it. The cosmic call transmissions of 1999 and 2003 were organized by a private company, working with a military facility, METI International, the organization responsible for the 2017 transmission toward Leighton's star, operates as a non-profit, with no formal accountability to any government or international institution. In each case, the decision was made by a small group. The consequences, if any, would be borne by everyone. This asymmetry between who decides and who bears the consequences is perhaps the most troubling practical dimension of the entire debate. A handful of people have made choices that could, under the assumptions of the dark forest theory, affect the survival of every human being alive today, and every human being who will ever live. Stephen Hawking brought these concerns to a far wider audience. In 2010, speaking through his television series, Hawking drew a comparison that many people found uncomfortably persuasive. He pointed to the history of European colonization and its impact on indigenous populations around the world when technologically advanced civilizations have encountered less developed ones on Earth. The outcome has almost always been catastrophic. For the weaker party, the indigenous peoples of the Americas, Australia, Africa, and the Pacific Islands were not destroyed because European colonizers were uniquely evil. They were destroyed because the power imbalance was so extreme that the colonizers' intentions, whether benign, indifferent, or actively malicious, mattered far less than their capabilities. Hawking argued that any alien civilization, capable of detecting our signals and travelling to Earth, or even of responding with destructive force, across interstellar distances, would possess technology so far beyond our current capabilities that we would have no meaningful defence and no reliable way of determining whether their intentions were peaceful before it was too late to matter. He was not opposed to the search. He supported listening, but he explicitly warned against transmitting. Announcing our existence to the cosmos, he said, without any understanding of who might be listening, was reckless beyond measure. But slowly the counter-arguments begin to take shape. METI advocates are not naive people. They are serious scientists and thinkers who have considered the risks and arrived at different conclusions. Their arguments deserve honest examination. Seth Shostak, senior astronomer at the SETI Institute, has described fears about alien hostility as irrational. His reasoning is straightforward. Any civilization capable of interstellar action would be so far advanced beyond us that our existence or non-existence could not meaningfully affect their access to resources. We have nothing they could not find more easily elsewhere. In a galaxy containing hundreds of billions of star systems, why would an advanced civilization bother with us at all? Douglas Vacock, president of METI International, argues that passive SETI listening is itself an implicit endorsement of contact. If we ever detect an alien signal, the response from Earth would be chaotic and uncontrollable. Individual governments, private organizations, amateur astronomers, and ordinary citizens with access to transmission equipment would all respond independently. Trying to control Earth's electromagnetic output at that point would be functionally impossible. So the question of whether to transmit is already settled, just not yet triggered. Others point to the potential benefits. Contact with a civilization, millions of years more advanced than our own, could provide access to knowledge, technology, and solutions to existential problems that humanity currently cannot solve. Climate change, disease, energy scarcity. The rewards of contact, they argue, vastly outweigh the speculative risks. These arguments have genuine merit, but they do not fully address the core logic of the dark forest theory. The theory does not claim that aliens are definitely hostile. It claims that you cannot know whether they are hostile, and that this uncertainty itself is the structural danger. The theory does not require advanced civilizations to want our resources or our territory. It requires only that they be rational enough to recognize that any unknown civilization represents a potential future risk, and cautious enough to act on that recognition before the risk materializes. Arguing that advanced civilizations would have no motivation to harm us assumes a level of insight into alien psychology that the chain of suspicion explicitly identifies as impossible to achieve. The governance vacuum compounds everything. As of today, there is no treaty, no binding international agreement, and no institutional framework governing who can transmit signals into space, at what power levels, toward what targets, or with what content. The United Nations Committee on the Peaceful Uses of Outer Space has never taken up the question in a binding capacity. The International Academy of Astronautics has produced voluntary protocols recommending consultation before transmission. But these protocols carry no enforcement mechanism and have been repeatedly ignored. This means the decision to reveal humanity's existence to the galaxy continues to be made by small groups of scientists acting on their own initiative, guided by their own assumptions about the benevolence of the universe. And then comes an event that adds a darkly ironic dimension to this entire discussion. The Yevpatoria planetary radar in Crimea, the facility from which some of humanity's most powerful deliberate interstellar messages were transmitted, including the cosmic call transmissions that announced our existence to multiple star systems, was destroyed in August 2025 by a Ukrainian military drone during the ongoing conflict in the region. One of humanity's loudest voices to the cosmos was silenced, not by an alien response, not by any force from beyond the stars, but by the same species that built it, in a conflict over territory and sovereignty, on a single small planet. The metaphor embedded in this event is not a comfortable one. A civilization that cannot resolve its own internal conflicts over the distribution of resources on a single world is simultaneously broadcasting its existence and location to a galaxy that may punish that visibility with consequences we cannot yet imagine. between the advocates who believe contact is worth the risk and the critics who believe the risk has not been honestly assessed as silence grows. Not the silence of agreement, the silence of a question that neither side can fully answer. With the evidence available, we do not know whether alien civilizations exist. We do not know whether they are monitoring our signals. We do not know whether the dark forest model accurately describes the strategic landscape of the cosmos. We cannot know these things in advance. We can only act under uncertainty and live with the consequences. But the critics are correct about one thing. The absence of evidence for alien hostility is not evidence of alien benevolence. It is simply absence. The same absence that the dark forest theory reinterprets not as emptiness but as discipline. The signals humanity sent are irreversible. The debate about whether they should have been sent continues without resolution, and the silence that greets them grows louder with every passing year. Slower now, more gently. The stars around you are as countless as they have always been, burning with the same patient fire they have maintained for billions of years, and something has changed in the way you see them. Something quiet and permanent. Because you have heard the logic now, you have followed it from its simple beginnings, through its careful, inevitable conclusions, and the universe, which once felt like an invitation, has begun to feel like something else entirely. Not a threat, not a darkness closing in, but a landscape with rules, old rules, rules that were written not by any civilization, but by physics itself, by distance and delay, and the irreducible uncertainty of minds that cannot reach each other fast enough to trust. You are beginning to understand the silence differently now. Look at the night sky from Earth on any clear evening. Thousands of stars visible to the naked eye, hundreds of billions more beyond what human vision can reach. Each one a sun, each one possibly warming worlds of its own. The sheer number of them should be overwhelming evidence that we are not alone. And perhaps we are not. Perhaps the galaxy is full of life that began billions of years, before Earth cooled enough to hold an ocean, full of intelligence that looked outward long before humanity existed, full of civilizations that built telescopes, developed mathematics, asked the same questions, felt the same longing for connection that we feel. When we turn our instruments toward the sky, perhaps they are all still out there, hidden, watching the darkness, moving silently through a universe they have learnt to understand, in a way that we are only beginning to grasp. The dark forest theory predicts exactly this outcome. Not a galaxy emptied by war or self-destruction, not a universe of failed experiments in biology, but a cosmos full of civilizations that have independently, inevitably arrived at the same conclusion. That the first rule of survival is silence, that every signal you send is a risk, whose magnitude you cannot calculate, that every civilization you reveal yourself to forces a strategic calculation you cannot control, that the only rational equilibrium, in a universe where trust is impossible and technological change is relentless, is to never let anyone know you are there. If this is true, then the silence we observe when we point our radio telescopes at the sky is not empty, it is full of civilizations that solved the same problem and arrived at the same answer, full of species that once felt the same longing for contact that humans feel, and learned, through logic or through the bitter example of civilizations that chose differently, to suppress it. not out of indifference. Out of wisdom, this transforms the night sky into something almost unbearable to contemplate. Every star becomes a campfire, around which someone might be sitting, watching the darkness, trying desperately not to be seen. Every quiet region of space becomes a hiding place. Every unanswered signal becomes confirmation. Not that no one is listening, but that everyone is listening, and no one is willing to respond, because responding reveals your position. And revealing your position is the one thing that every surviving civilization has learned never to do. The question we should have been asking all along is not why the universe is so quiet. It is how the universe got so good at being quiet, and what happened to the civilizations that chose to be loud. But slowly something else settles into this picture, something that is important to hold. Alongside the darkness of the theory, the dark forest is not proven. It is a framework, a hypothesis built from axioms that are defensible but not inevitable, and the objections raised against it are serious enough to prevent certainty in either direction. Perhaps the diversity of alien minds is so vast that the theory's logic simply does not apply universally. Perhaps some civilizations exist in forms so different from biological life that resource competition, territorial anxiety, and strategic suspicion have no meaning for them whatsoever. Perhaps intelligence, evolved under radically different conditions, does not converge on game-theoretic rationality. The way the theory assumes, perhaps cooperation is possible, even across interstellar distances, in ways we have not yet imagined. Perhaps advanced civilizations have developed signaling mechanisms, verification technologies, or institutional frameworks that collapse the chain of suspicion in ways that seem impossible. From our current vantage point, perhaps the costs of interstellar conflict are so enormous that no rational civilization would ever find preemptive action worth the expenditure of resources required. Perhaps the galaxy is simply large enough that civilizations expand into uninhabited regions without ever needing to compete with or threaten each other. These possibilities do not eliminate the dark forest logic, but they reduce the certainty with which it applies, and that reduction matters enormously when you are deciding how to interpret cosmic silence, and yet the conditions the theory identifies as drivers of its conclusion are not speculative. They are facts. Interstellar distances are genuinely vast. Communication delays are genuinely measured in years and centuries. The intentions of alien minds are genuinely and permanently opaque. Technological development genuinely transforms primitive civilizations into dangerous ones within cosmically negligible periods, and there genuinely exists no enforcement mechanism capable of guaranteeing that any agreement between civilizations separated by light years will ever be honoured. These are not assumptions the theory makes up to reach a frightening conclusion. They are features of the universe that physics itself has written into the structure of reality, and they make the dark forest logic not certain but deeply, persistently plausible. What does this mean for humanity? We are a young civilization, barely a century into our electromagnetic existence. We have been sending signals. For roughly 100 years, intentional and unintentional, into a universe whose rules we are only beginning to understand. We have done this with the confidence of a species that has never been answered, and does not yet know what an answer might cost. We have called out, the signals are travelling, they cannot be recalled, and here is where the emotional weight of the dark forest theory truly settles, not in the fear of what might happen, but in the recognition that we made these decisions. Without fully understanding the universe, we were making them in. The asymmetry at the heart of the situation is worth sitting with quietly. If the universe is empty, our signals do no harm. They travel forever through the dark, reaching no one, changing nothing. If the universe is full of life, too primitive or too distant to detect us, our signals do no harm. They dissipate into background noise, before reaching anyone capable of acting on them. If interstellar communication is physically impossible, for reasons we have not yet discovered, our signals do no harm. But if the dark forest theory is correct, even partially, even approximately, even as a rough description of the strategic landscape that some fraction of civilizations in the galaxy have converged upon, then every signal we have sent carries risk. Risk whose magnitude we cannot calculate, risk whose consequences we cannot reverse. The rational response to this asymmetry is not panic, it is not despair, it is not the abandonment of curiosity, or the surrender of hope. The universe is extraordinary. An exploration remains. One of the noblest things a mind can pursue, but the rational response does include something that humanity has not yet fully demonstrated: humility. The recognition that irreversible decisions, with existential consequences, deserve more careful deliberation than a handful of scientists acting on their own assumptions about the benevolence of the cosmos. The night sky is quiet tonight. It has been quiet for every night of human history, for every generation that looked up and wondered, for every civilization that built instruments and listened, and heard nothing definitive in return. We have interpreted that quiet as loneliness, as emptiness, as an invitation to fill the void with our own voice. But there is another interpretation available, one that does not require us to be alone, one that allows the galaxy to be teeming with life, with intelligence, with civilizations far older and wiser than our own. An interpretation that asks only one quiet adjustment to our assumptions. What if the silence is not empty? What if the silence is full of listeners? What if every civilization in the galaxy, having followed the same chain of logic, through the same inevitable conclusions, arrived independently at the same place? We are only now beginning to approach the understanding that in this particular universe, with these particular rules, the most dangerous thing you can do
is let anyone know you are here. We are young. We are loud. We are beautiful in our openness. And our hope. And our longing to be known.
that the universe is old, and it is patient, and it operates according to rules that do not change, simply because a young species has not yet learnt them. The signals are gone, travelling outward at 300,000 kilometres per second, carrying our location, our technology level, and our extraordinary willingness to be seen. The universe has heard us, or it has not. We may never know which. The timescales involved mean that if a response is coming, it might not arrive for decades, or centuries, or longer, and in that long silence, Between the sending and the possible answer, something important can happen. Something that does not require despair or fear, or the abandonment of wonder. We can become wiser. We can approach the cosmos. With greater humility, we can recognize that the ancient longing to be known, to be heard, to be answered by a voice from beyond the darkness is one of the most beautiful impulses our species possesses. And we can hold it, alongside the quiet understanding that the universe may not reward that impulse in the way we have always hoped. The cosmos is not necessarily empty. It might be full of civilizations that have learned to survive by mastering a single quiet discipline: silence. Not the silence of absence, not the silence of failure, but the silence of wisdom, the silence of civilizations that looked outward, understood the rules, and chose to endure. The stars keep burning, the darkness keeps stretching, and somewhere out there, in the vast patient quiet between the lights, something might be watching, listening, calculating,
and choosing very deliberately to say nothing at all. Let the stars hold you now. You have drifted a long way tonight.
Through the beauty of the cosmos and the weight of its silence, through the hope of contact and the logic of caution, through questions that have no easy answers, and truths that sit quietly at the edge of what we know. You do not need to carry all of this with you into sleep. The universe will hold these questions while you rest. It has been holding them for 13 billion years already. A few more hours will not change the stars. You are small and safe and here, breathing slowly in the dark of your own small world. And whatever the cosmos holds, beyond the light of your window, it holds it patiently and without urgency. Let the silence become gentle again now. Let it return to what it was, before all the questions began. Just space, just distance, just the quiet company of stars.
Burning through the night, you can rest here among the stars.
If this journey moved something in you, if it made the universe feel a little larger and more mysterious, consider subscribing and staying with us on this slow drift through the deepest questions of existence. The cosmos has more to show us. And we have time. Rest now. The stars are keeping watch.